students with the God. Useless knowledge.
He is an Argentinian player, right? But he is not in the squad right now, I think.
Maybe more.
Now he is in currently Kerala strike. Oh, now he's in some kind of classic. But before he was in, he was in where it is. And then, Paris. But he was not in the main team for so long. From Paris, I think he got like selling. Easy.
Okay, now students need to show something. I need something. Oh, I need this. I need a bigger scope. This. Oh, I have to use anonymous first. Good day for you, anonymous. I got something for today. What's wrong with my camera? Oh, no, it's better. Okay, let's go forward. I have a tiny demo here. I have assembled a very simple network. I have signal, source, signal generator, a resistance of 600 ohms, capacitor 0.1 microfarad, and I took two signals to the scope. S1, it's a yellow line on the scope, and S2, it's a blue line on my scope. Second, I can move closer. Upper is my resistance box set to 600 ohms, and lower box in microfarads, only one plug, 0.1. Switch here. Yeah. Let's try to see what happens if sit here with comfort, and I will change frequency. See measurements. I put an effective values on RMS for both signal for on the right side, for yellow and for blue. Oh. One moment. First I need to shift camera a bit, because my measurements are not visible. I will switch to the second camera. Try to bring measurements. Refuses to go forward. Here, measurements. I'm changing frequency. Frequency increases. Frequency decreases. At 400 Hz, they are near equal.
Professor, why if you change the frequencies, the amplitude is also changes?
Yeah, that's what I like to draw on tape. Second, here is my circuit, resistance, capacitor. Yes. Let's assume I have an AC source. One, resistance, capacitance, and for example, I have here voltage put. Can I write output voltage as a function of input voltage in terms of classical electrotechnics? What it will be? I can substitute this network with resistance and XZ, yeah? So, there will be U1 multiplied by 1 divided divided R plus 1 divided by omega c, where J is a square root of -1. Is it correct from electrotechnic basics? Angnanimus leftas. Correct from electrotechnic basics? Yeah. Can I draw a chart? U divided by U1 as a function of frequency. Possible. I have frequency here and I have frequency here. So if frequency is 1, DC mode, what will be radio?
So can you repeat?
DC mode, frequency 0,
Then
DC mode. What will be radio? Capacitor will be infinite and radio will be 1. In case frequency is infinity, what will be output? This one will become 0. So output will be 0 and this radio is 0. So this chart starts from 1 and ends at 0. You can check. It will look something like this. If I draw it in correct scale. The higher frequency, the lower is equivalent resistance of capacitor box. Let's take a point 1/2. 173. What's 1/2 of 173? It's, approximately 0.66. Where is midpoint? Approximately 0.66. Oh, here is approximate point where it's 1/2. Rate is approximately 1/2. 4.7 kilohertz. What happens if I double the capacitance?
Then
What happens with this knee point? Double capacitance.
I think it won't change. Or
No. If I double the capacitance, knee point will go towards 0 by 1/2. Wait. Take a look. See? Knee point now 4.7. I'm adding 0.1 microfarad. Sorry, in opposite direction as it needs 0.8 or 2.3. See? Twice. Now frequency when ratio is 1/2, sorry, 1/2 at 2.4 kilohertz. Nice chart. What this chart tells us about this network? What this network passes low frequencies and suppresses high frequencies. Yeah? Correct? Yeah. The name for such charts, Bode plots or amplitude frequency diagram. How the transfer ratio changes as a function of frequency. It's a very good characteristic of circuit. Bode diagram or Bode plot.
So U2 over U1, we call it.
Yeah, it's a transfer ratio.
We call it gain, yeah.
Yeah, 1 second. I can rewrite U is U1 multiplied by some function of frequency. Can I write this way?
Yeah.
It's a complex function because it's from electron to omega. Bode plot actual is a absolute value of model of transfer function as a function of frequency. The way I wrote it, in my case, transfer function, or I can write it as a function of complex frequency, will be 1 divided C divided R plus 1 divided by omega C. Transfer function H as a function of omega. And Bode diagram is a absolute value or magnitude of transfer function as a function of frequency. Can you tell, are you familiar with Bode diagram? No? You never saw graphic equalizer in your life? Equalizer. Lower frequency, higher frequency. Really? You never saw an equalizer in your life?
Maybe you've seen, but maybe it was called.
It wasn't called Bode plot. It was called graphic equalizer. When you have low frequency, middle frequency, high tones, and not spikes, you can draw them. Yeah, and
You mean in frequency domain?
yeah, frequency. It's
Yeah,
usual
so-
thing for good quality acoustics.
Yeah, I've seen.
Graphic equalizer is a way to synthesize kind of Bode diagram or transfer function for your sound. What will do this network? It will suppress high frequency. So, boom, boom, boom will go unchanged and will be suppressed.
Yes. So
Name for this circuit, maybe LPF. What means LPF? Low pass filter. Low pass. Passes low frequency, suppresses high frequency. My network is a low pass filter. Something like this. You can take any book, and in most books, this will be called midpoint, and this one will be written as a 6 decibel oct per octave. When you look at Bode diagram or something like this, measurements decibel per octave. What is decibel and what is octave? Octave means 1 octave, omega 1, omega 2. Omega divided by omega 1 is equal to 2. 1 octave means frequency changes twice. It's from sound. And what is decibel? Bell actually is a decimal logarithm between some values. 1 bell. But because bell is a very high, usually decibel is used. So if we have voltage, current and something like this, decibel is 20 decimal logarithm of, let's say, x2 by x1. It's a ratio. 6 decibel is approximately 2 times.
This is x2 or x1 is
Some values.
magnitude of transfer
More than
function.
anything, yeah. If we speak on transfer function between points, this will be approximately 2 if we have 6 decibels per octave. If frequency doubles, amplitude decreases twice. It goes down with approximately 45-degree slope. Okay. Decibel is used for relative. For power, 1 second, for power, not 20 but 10. It's for power. And one more thing, many, just for understanding, 20 decibel means 10 times, 40 decibel 100 times, 60 decibel 1000 times. There is a style when on volt gauge are decibel scales. They are relative. Decibel is a relative value as same as percent. For voltage measurements, as a base level, used voltage producing 1 milliwatt on standard communication line resistance, and this resistance is 600 ohms. Typical overhead old-time communication wire has a resistance of 600 ohms. So, approximately 0.7 or 7 volts is a base level for decibel measurement in voltage. 1 milliwatt at 600 ohms. It's just for knowledge. Do not run away if you see voltmeter graduated in decibels, not in volts. Like, for example, this one. This thing has a measurement in decibels. Why they are calling me? I'm busy. Norma nu akceptē, notiek kaut kā. my God, I forgot to sign important paper. Sorry. It's HR called me. I forgot to sign one document. Okay. Can we assemble another network? This one was simple, yeah? But hey, 1 second. Before I disassemble it,
Is it say body plot but with phase diagram? Yeah. Is it?
yeah, can be if needed. Okay. 1 second. Watch the face.
Yeah, it shifted to
High frequency. What's the phase shift between output and input? 90 degrees. Yeah?
Yeah,
It's
I
90
think so.
degrees.
Yeah.
Low frequency. And phase shift goes towards 0.
Yeah.
0. It's because capacitor current is high and high. At infinite frequency, phase shift should be ideal 90 degrees. Okay, what I would like to do. What kind of signal do we observe? Harmonic. Harmonic, ideal sign. What if I push a button? Not harmonic, but
Okay.
rectangular. Wait.
Um,
Sine input, sine output, is okay. Square. Squares and input and something strange in output. You see it? Triangles. Also distorted. But squares. Sine, everything fine. This frequency. That's what happens with squares and with triangles. Maybe turn to sine. Something? They don't telling us everything. When we are, how to say, in domain of electrotechnic classics, everything fine. Input harmonic, output harmonic. But there's something bad. This one isn't so good. Okay, what I would like to do, I would like to change my network. I would like to have this kind of network. Transfer function will be f plus 1 divided. What can we expect from such network? Voltage, where are you? Here's my voltage.
I think if frequency approaches to 0, the gain approaches to same 0.
Yeah, so output will be
Yes.
0. And if frequency is infinite,
And the gain is also
output will
output
be,
also.
input will be equal to output. So ratio will be 1. we can expect something like this. Or HTF, high pass filter. Let's check. Oh, sorry. I forgot to attach. Okay, let's check. Frequency increases, ratio comes closer to 1. Frequency decreases and output goes down. For phase. Low frequency, 90 degrees. High frequency, and goes toward 0. And what about non-harmonic signal? Whoa, whoa, whoa. And for triangles, this is for triangles, this for squares, and for harmonic signal. Squares, triangles, fine. Again, harmonic signal passes non-disturbed, while non-harmonic signal suffers from heavy distortion. Input squares, output spikes. Sine at input, sine at output. Something bad happens here. Maybe it's something about capacitors.
If we change the capacitor, like if we increase it, I think it.
Which way key point goes? If I double.
If you double capacitor, I think it.
Go to the right.
Yeah, it. The output.
See what happens. Output. If I double capacitor at a particular frequency. Okay, well, let's catch it. We need 600. 866. Okay. Here 866 at 1.4. Yeah? I'm doubling capacity. And 866. I need to decrease frequency. Key point goes. Here, approximately. 2 times lower frequency. Key point goes towards me. Okay, what I want to do. Capacitor is good. Good? Good. What's on the other side of capacitor?
The capacitor, if capacitor, how to say?
What electrotechnics teach us? On the one side is capacitors, on the other coils?
Yeah.
Coils. Coil, where are you? my beauty. 1/10 of Henry. Oh. Coil, 1/10 of Henry.
What does it mean? 1/10?
Of capacitors are measured in farads, millifarads,
Yeah, I got it.
microfarads.
You mean-
Coils are measured in Henry.
Yeah, I know.
And
about
this
Henry.
100 millihenries or 1/10
You mean tens?
tenths.
And-
Yeah. Take 1/10.
Uh-huh. It's exponent 10, yeah?
1/10 of Henry. Or 100 milli. Standard self-inductor. Tinsley and Company, London, SE 25. And I need now my circuit is what will be transfer function?
G W
R
R
divided R plus
plus G W L.
yeah omega. It's a Greek omega. Let's check. Frequency decreases, output increases. Frequency increases, output goes down, decreases.
Output, yeah, if the frequency increase, output decreases.
APF. And what about non-harmonic signal? Oh, angle. Low frequency,
Is it
high frequency. The higher frequency, the closer angle will be to 90 degrees.
in low, it's approach to zero, yeah?
At infinite, it will go 0. At a DC mode, transfer will be 1 and angle
No, I
will
mean
be 0.
phase shift angle.
Yeah. Phase shift.
Like if it is, if in low frequency,
In
it
low
will-
frequency,
it will
it
be
goes
zero.
to 0.
Yeah.
At high frequency, it has a limit 90 degrees.
So professor, is phase shift maximum reached to 90 degrees?
For such network, yeah. For such network, 90 degrees.
Mhm.
So what about square? Distorted. Triangles. Distorted. Sine, not distorted. Maybe try different coil. 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 if you have large coil, you need a small coil. This one is 10 times smaller. 10 millihenries. And also one. And knee point shifted 10 times. Much higher frequency needed. And what about non-harmonic signals? Change distortion. We again observe distortion. One more network.
Like coil and capacitor, you mean?
From set RCRA remain this one. Yeah? Transfer function will be omega n divided by f omega n. Like this. Should be an high pass filter. Let's check. You can something this is ground. Come on. Signal. This goes here and where is my oh, let's check. Low frequency, output goes
No.
to 0. High frequency, they are nearly equal.
Near equal.
And what about phase shift? This is low frequency, 90 degrees. High frequency, and phase shift goes to 0. At infinite frequency, output will be equal to input. And what about distortion? Wow, 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 wow. See what happens? Something bad. Input harmonic, output harmonic. Input rectangles, output some kind of spirals. Input triangles, output squares. Something wrong here. Yeah? When I'm in comfort zone, like to say, electrotechnics theory gives me a comfort. Everything stands on ground. But if I go outside the box, something happens. Real. Something is wrong here. I need to do something. This is definitely at last suspicious. Find something more suspicious.
So something is wrong with rectangular
So,
signal.
see, if I have harmonic input,
Yes.
I have harmonic output. So if input sine, output sine. If input cosine, output, okay, it's cosine. How to say, signal nature don't change. But if I have rectangles at input, I will not get rectangles at output. Nature of signal change. It's something wrong.
Because, for example, rectangular signal is sum of a lot of harmonic signals, like different amplitude, different frequency, sum of.
It's not an uniform. It's not a single frequency signal.
Yes, that's what I mean.
Next time we will take a detailed look at this, and we will understand why this generator is so huge. I will not start this new monsters now, but I would like to show maybe one more network. One more. One second, I will assemble one more circuit. I will need small capacitor. One second. More networks to the god of networks. We go here and This wire not connected. Bit more funny. I have assembled network like this. Input output. This capacitor is not important.
So output voltage is connected. One of
This one is output.
yeah. Let's
And here is one. This one is yellow. This one is blue. What is that? I'm changing frequency.
and so how it will be equations for this one, the transfer function.
Input half of volt, output 0.7. I can reduce 2 times capacitor. Oops, this is fun. Input half of volt, output 2.6. It's a it's a second order or resonant network.
So, if it is resonance, then this coil and capacitor canceling each other? Or?
No, cancel not not a good word, compensate. We can write a resonance condition or covenant as imaginary part of A 0 being 0. Resonance condition will become when input conductivity of this part becomes 0.
So, okay, then
It yields us frequency 1 divided by square.
so how the transfer function will be?
How transfer function will work? One second. C1 coil C2 ground ZA, this is A point is omega multiplied by 1 divided by your omega C divided omega L plus 1 divided by your omega C. And a transfer function itself is A divided is C2 your omega C1 1 divided by your omega.
S1
1
plus
divided by your omega C1 plus
ZA.
yeah. Actually, this moment I need this capacitor to isolate resonance part from the very low output resistance of my generator. My generator has output resistance only of 50 ohms. So to make effect visible, I need this 1 nanofarad, 1150 picofarads. It's even shorter. Actually, this capacitor is, I don't know, 80, 90 years old. That's characteristics. I can do one thing, I can switch to rectangles. Number 1, put rectangular signal. Point number 2, interesting point number 1, input rectangle, output sine. Point number 2, input rectangle, output sine, the triple frequency. and
Professor.
5 times.
Professor, why input is rectangle right now?
Because I ordered it.
Ah,
Because
you
I
did-
pushed a
Aha,
square
okay,
button.
Okay, okay, you did.
I can use triangles.
Uh-huh.
I can use rectangles. I can use sine. Oh. Input sine, output sine. Input squares, output sine. Input triangles, output sine.
So right now here, transfer function gets its maximum value when
It has maximum value at a point
capacitor.
compensate the square.
Uh,
Condition for this point, we will see more precise, but at first approach, this point is 1 divided by square root of LC. Condition of current resonance. Something happens here, yeah? And take a look at amplitudes. Input 0.7, output 3.2. This is difference. Free energy. Output higher than input. In volts. Okay, I think it's enough for today. But I need